Sometimes instead of being given a point-slope form equation, you'll be asked to write a point-slope form equation. Remember that point-slope form is our third linear equation form. Y minus y1 equals m times x minus x1, where one point on that line is given in the equation, x1, y1, and the slope is m. When you're writing a point-slope form equation, you need to subtract the x and the y coordinates. In this first example, x1 is 2, and y1 is negative 5. I'm therefore going to plug 2 in for x1 and negative 5 in for y1. My equation is y minus negative 5 equals negative 3 times x minus 2. We need to rewrite minus and negative as plus because this is not very pretty. Y minus negative 5, we rewrite as y plus 5 equals negative 3 times x minus 2. This first line is not required if you're really comfortable with point-slope form and you know that if the y-coordinate is negative, then we're just adding. That's totally fine. Writing this first line is probably more helpful in terms of making sure you don't make a small mistake, but I'm okay with either. Next example, now x1 is negative and y1 is positive. Y minus y1, y minus 6, equals slope of 2/3 times x minus my x1 minus negative 3. Again, we will rewrite that minus and negative. Y minus 6 equals 2/3 times x plus 3. First line not required. If you know that if the x coordinate is negative, we're adding it, that's great. Another skill that's really useful with point-slope form is being able to transform from point-slope form into slope-intercept form, y equals mx plus b. If you notice, if you recall, these two equations are actually the equations that we graphed on our previous notes page. Y minus 4 equals 2 times x minus 3, y plus 3 equals negative 1/2 x plus 2. Therefore, it's really, really useful to transform a point-slope form into slope-intercept form so that you can check your graph. You can check that it has the proper y-intercept. The transformation is really straightforward. We just use the distributive property and then add or subtract y1. Let's do that. So first I need to use the distributive property. 2 times x is 2x. 2 times negative 3 is minus 6. Transformation is complete after I add 4 to both sides. Y equals 2x minus 2 is my slope-intercept form of this equation. These two equations represent the same line. This is in point-slope form, this is in slope-intercept form. I'm going to go back and check my first graph. What should be the case? The slope is 2. The slope is the same in the two forms, but I should have a y-intercept of negative 2. Let's check. Yay, hooray, my y-intercept is in fact negative 2. That means I did graph correctly. Let's check the next one. Y plus 3, negative 1/2 times x, negative 1/2 x, and then negative 1/2 times 2, that's just minus 1 or plus negative 1. So distributive property and then add or subtract y1. So I'm subtracting 3. That gives me my slope-intercept equation. Y equals negative 1/2 x minus 4. These are the same line. This is representing the line in point-slope form. This is representing the line in slope-intercept form. Same slope. I'm just going to check my graph and I'm going to make sure that my graph has a y-intercept of negative 4. It does. Phew, I don't have to remake that video. My y-intercept is negative 4 and I graphed correctly. Transforming from point slope into slope intercept form is really, really useful. I want you to be able to graph directly from point slope form using the point and the slope, but then you should check it by transforming.